let's say your function in your brackets looks a little different. Let's say it doesn't start with the number 1. Let's say instead it starts with a different number. A plus bx to the power of n. If that is the format of your function and n is negative or a fraction, then your expansion is valid for the modulus of b over ax being less than 1. Let me write that 1 there. Or the modulus of x being less than the modulus of a over b. That's just something I want you to remember. But if we have something like a plus bx to the power of n, how do we apply the binomial expansion? Here's what you do. I'm going to go through part A, and it's going to be probably the best way of explaining it, really, if you see me do it. First off, you've got root 4 plus x. Can you put that into brackets, please? 4 plus x to the power of a half. Nice and easy. Here's what you're going to do. You are going to convert this into a bracket including 1 plus. So starting with 1. Just how we've looked at expanding this, right? But now we're expanding this one. What you're essentially going to do is turn this into that and then expand it. The way you do that is by factorizing out the first number. I'm going to take out the 4. When I do that, I have to apply the power to it. Like this. And now, inside my bracket, I'm going to have whatever's left. 1 plus x over 4 to the power of half. Because I've factorized out the 4, I'm left with x over 4. Okay? What is 4 to the power of a half? 4 to the power of a half is the same as root 4, which is 2. So 2 times 1 plus x over 4 to the power of a half. And now you do the expansion as per usual. But you're going to start with 2 on the outside, and you're going to have a square bracket like that. And then you apply the binomial expansion to 1 plus x over 4 to the power of a half. So, can you try that for me, please? Okay, we start off with 1 plus n times x plus n times n minus 1 all over 2 factorial, and then x squared. And then we'll go one more term, n minus 1, n minus 2, over 3 factorial, x cubed, plus blah blah blah. We don't want to go too long. Now, it's a matter of simplifying what's inside those square brackets. So, after plugging all that into your calculator, you should get 1 plus x over 8, or an eighth x, minus x squared over 128 plus x cubed over 1024 plus blah 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 blah. And now you can times every term inside that square bracket by 2. When I times x over 8 by 2, I get 2 over 8x. But that simplifies to 1 over 4x. So after simplifying, I'm going to have x over 4. Okay. After timesing by 2 and simplifying, you get x squared over 64. After timesing by 2 and simplifying, you get x cubed over 512. And then you have the rest of your expansion. This is valid when the modulus of b over a is less than 1, right? Or x over 4 modulus is less than 1, which is the same as the modulus of x being less than 4. Just take the 4 to the other side. There you go. That is how you expand if you have a number at the start of your brackets. That's part A. Can you try the expansion for part B? And remember, you only want the first 4 terms, and then you want to find the range for which it's valid. Okay, let's rewrite this into brackets, which becomes 2 plus 3x to the power of minus 2. And now we're going to factorize out the 2, making sure that we implement or apply the power to whatever we've taken out. Square bracket 1 plus 3 over 2x to the power of minus 2. Let's apply the square bracket. Actually, let's go with the regular brackets for now. 2 to the power of minus 2 is the same as 1 over 2 squared, so 1 over 4. Now I'm ready to apply the binomial expansion to the brackets. So we put 1 over 4 on the outside, we do our square bracket now, and then this is going to be the start of your binomial. So when you're plugging everything in, I mean 1 plus n x plus n minus 1, 2 factorial, x squared, n minus 1, n minus 2, 3 factorial, x cubed. That's what you should have after plugging it all in. And now it's just a matter of simplifying. After simplifying, you should have 1 minus 3x plus 27 over 4x squared minus 27 over 2x cubed. And after timesing everything by a quarter, you should have that. Your 3 over 2x modulus being less than 1 is the same as your modulus of x being less than 2/3. That is the range. And there you go. That is the second part of using the factorial notation in binomial.